Good afternoon, everybody. My name is Maritza Mills. I am a senior product manager with Route 53, and over to my right is
Jeff Damick, and I'm a senior engineer on Route 53.
And today we're going to be talking to you about a feature that we released just last week on a Monday, which was the Amazon Route 53 resolver. So going over the agenda today, the first thing we're going to talk about is what exactly is Route 53 resolver, just at a high level. And then we're going to get into the details of what those challenges are that Route 53 resolver solves. So what were the challenges that you were facing that we're solving with this? How are we solving those challenges? And in the middle of that, I'll hand it off to Jeff, and he'll kind of give you a deep dive into how that's working in the background. And then we'll do a short walkthrough of how you can get started, and we'll leave some time at the end for questions. So at a high level, what is Route 53 resolver? So in short, what we released is a feature as a part of Route 53, which is a managed DNS resolver service. So for those of you who use Amazon Virtual Private Cloud, typically you had something that you might refer to as the Amazon provided DNS server or the +2 resolver that comes available by default in all Amazon VPCs. If you're not familiar with it, that's good because you've never had to think about it. It just works. But for many of you who are operating in these hybrid cloud environments, you had to do some configuration to get DNS, specifically recursive DNS, to work. And just to take a step back, maybe for some of you who aren't familiar with the difference between authoritative and recursive DNS, for many customers, traditionally you've thought of Route 53 as an authoritative DNS service. That is, we have the final answer, the A record for whatever name that you're looking for. The recursive DNS service is usually what's doing the actual lookup against those name servers to get the answer back for you and deliver it back to the client. So it's just two different functions of basically the same process. So what we've done today is take that +2 resolver, take that Amazon provided DNS, and actually built features on top of it. So one of those features that we built, which I'll get into more detail, is a conditional forwarding rules. So you'll be able to take names like example.com and forward them to the DNS server that should be able to find the answer that you're looking for. And all of this was done ultimately to enable hybrid cloud so that you can perform DNS lookups across AWS Direct Connect or managed VPN, regardless of where those names are actually hosted officially. So what challenges does it solve? I want to dive into some deeper details for you. So this is a very simple example of what many of our customers were going through. They had a data center that was on premises, and they needed to do a DNS lookup against a record, maybe that's in a Route 53 private hosted zone that was actually in an Amazon VPC. The problem was that the recursive DNS server that was on premises was not able to resolve those names. In reverse as well, if for some reason Amazon VPC needed to resolve a name that is actually hosted on premises, it was not able to perform those lookups either. So what a lot of you did as kind of a workaround to that situation is create your own DNS resolver as kind of an intermediary between the +2 resolver and the Amazon, as your on-premises DNS server. So some of you decided to spin up EC2 instances, and you might have installed some kind of open source software. So the most common ones that we heard were bind or unbound, which meant that you had to install and patch your own servers. And you might have installed it in this VPC and used it as a forwarding target for that on-premises DNS server. Then what you would do is, depending on whether or not that name was local to your VPC or not, you could forward names back to the +2 resolver, or you would forward them across AWS Direct Connect to whatever that DNS server was on premises. I should mention, too, really quickly, I know many of you were using EC2 instances, but I do know some of you were also using kind of third-party virtual appliances as well. So regardless of which ones you were using, what we're looking to do is make it so that you don't have to use that anymore just to get DNS, recursive DNS lookups. So this is a little bit more complex. It's simple for the sake of the conversation. We know that many of you have hundreds of VPCs across multiple accounts. So I just wanted to make it a little more complicated and kind of speak to that scenario. So it's the same idea. You have an on-premises data center. It is trying to look up a name that is, say, in a VPC. So in this case, we have one direct connect back to the VPC that's in account 1. And you might have 2 other VPCs that are peered to it that are in 2 different accounts. Similarly, it can't resolve those names from on-prem. You also probably can't resolve names that are on-prem from either of those VPCs that are in this diagram. So in a similar fashion, customers would set up custom DNS resolvers or DNS forwarders in their VPCs. There's actually two ways that this happened. So some customers, depending on their needs, just had a set of centralized DNS forwarders that were kind of in that hub VPC that's connected back to on-prem. But for some customers that needed to resolve names such as private link or EFS, and they needed those VPC-specific answers, they actually had to put a forwarder in every single VPC. And even still, for some customers who wanted very high levels of availability, they were actually putting a forwarder in multiple availability zones inside of each account. So as you can tell, that starts to become, expensive in terms of scaling for cost, as well as just complexity as well. So what have we built? How does it solve this for you? So going back to before, instead of having to run your own forwarders, whether centralized or in every VPC or every AZ, you can actually just have a single endpoint. So these endpoints can run for multiple VPCs across multiple accounts inside of a single region. So as long as all those VPCs and all those accounts are in the same region, that endpoint can service all of those, even in the event that they are not peered, which I know that's how it looks in this diagram. And you get the bidirectional query resolution. The queries, in this case, always have to pass through an endpoint if they're going to go across either VPN or Direct Connect. And we'll get into a little bit of the details with the rules, but just kind of in short, you can have rules that are, say, in account 2 or account 3. And what they'll do is they'll take those queries, it'll follow the +2 resolver through the endpoint that's in account 1 and forward it back over to your on-premises resolver. So just diving into a little bit of detail, with a resolver endpoint, all query traffic has to go through either an inbound endpoint or an outbound endpoint. What happens is that an endpoint is made up of one or more elastic network interfaces, and each elastic network interface corresponds to a single IP address. So for those of you, when you're in the console or the API and you're asked to add an IP address, you're actually creating another elastic network interface. These IP addresses are pulled from your own subnet space of the VPC that is hosting the endpoint. And what we do recommend as a best practice, though it's not required, is that you have an ENI in a minimum of 2 different AZs just for availability purposes. Okay, so I want to talk a little bit about the benefits to you of Resolver and what we've launched. So speaking back to what I mentioned earlier, especially for those customers who were having to run a forwarder in every single VPC or every single AZ, you're going to see a lot of reduced complexity. So as I mentioned before, you should not have to run these at all. You should be able to change your DHCP option sets back to using the Amazon-provided DNS server, and really just run one endpoint or maybe 2 endpoints for the entire region, even if those VPCs are in different accounts. And in some cases, especially talking to some of the customers that we've spoken with, this means you could be going from, say, 100 forwarders or maybe 300 forwarders to just one endpoint. It really depends on how your architecture is configured, but this should reduce the complexity greatly for you. Another benefit to you is availability. This is especially true, I think, for those customers who are running centralized forwarders. For many of you, you were going from having the AWS backbone to depend on to forwarding all your queries to this one set of centralized DNS servers. And what that meant, if something happened to that centralized set, then none of your VPCs were actually able to resolve DNS for that period of time. So what happens is that since you're now able to go back to using Amazon-provided DNS, first off, all of the query resolution now returns local to your VPC, so it's distributed in that sense. And even in the case that you do need to forward them back across Direct Connect or VPN, you still have the added availability of AWS architecture. And if you need even more than that, you could always add additional AZs for your ENIs. Another benefit that I mentioned earlier is maintaining VPC-specific answers. So we saw this the most with customers who are using private link. What happens first when the rules are running is that when a DNS lookup is performed with the .2 resolver, it's happening local to your VPC. It will check to see if you have any forwarding rules that are saying, hey, this particular name, say example.com, needs to actually be resolved from an on-premises DNS server. In which case, if it does see one, it'll forward it. Otherwise, it will just resolve locally to the VPC. And then even still, if it's not local to the VPC, it recurs back out to the public internet. So it just follows the default behavior when there are no rules present. Another benefit to some customers, especially those with high query loads, will be eliminating bottlenecks. So some of those customers with high query loads, if they were running centralized DNS resolvers, ran into the 1024 packet limit, and they were experiencing some throttling issues. In this case, you should not experience that, first of all, because, again, the query load is being redistributed back out to your individual VPCs, so that solves your first problem. But second, for those of you who might still have a high query load just going back and forth between on-premises and AWS, the individual ENIs have much higher loads that they can accept. It's up to about 10,000 QPS, and that's per ENI. So you could actually get created if you wanted to and even add more ENIs just purely for the higher query loads. Another benefit that has been added is cross-account rules sharing. So we heard from many of you that one of the things you didn't like doing was having to manage individual forwarding rules in multiple different accounts. So what we've done is we've actually integrated with Resource Access Manager, which was released recently along with our feature as well. And what that'll let you do is you can create all of these forwarding rules from within one account. So let's say you wanted to create them from within account 1. You can then choose to share those rules with accounts 2 and 3 or however many accounts you have. The only action that has to be taken on the part of accounts 2 and 3, for example, would be that they still apply those rules to their VPCs, but all the management and the sharing could be done from a single account. So how do you get started? I'm just going to walk through the console experience with you a little bit just to show kind of what is the process of setting up an endpoint and setting up these forwarding rules, and then I'll hand it off to Jeff. So the first thing that you would do is choose an endpoint. So for some customers, for most customers, you're probably going to want bidirectional query resolution. So each endpoint serves a single directional purpose. It's either letting queries out of the VPC or it's letting queries into the VPC. If you do just need one, you can just choose one. Otherwise, you'll create an endpoint for both inbound and outbound traffic. When you are creating that endpoint, you can give it a name. This is just a friendly name, making it easier to find later. This is not the same as a tag. You'll choose the VPC that it's going to be hosted in, and this is a reminder that it is a regional service. So I know most of Route 53, all of Route 53, is a global service today, but this specific feature is regional, since your VPCs are regional. When you configure your endpoints, you'll be asked to choose a minimum of 2 IP addresses. This is a best practice. You can choose to remove one if that doesn't suit your use case, but we do recommend it, and at least 2 different AZs. When you choose your subnet, we can automatically assign an IP address from that subnet space, or you can actually choose what IP address you want. And this is a stable IP address that you can use as a forwarding target or to configure for your firewall that's on premises. And also, in addition to naming, you can always tag your endpoints as well. So if you choose an outbound endpoint, and this is the only case where that applies, if you have an outbound endpoint, you're expecting traffic to leave your Amazon VPC and go to an on-premises DNS resolver. In that case, you're going to create a forwarding rule. You can give the rule a name if you like. You will then choose one or more VPCs that apply to this rule, and you can do it from within the screen. You can always go back and add more later. And then you will choose the domain name. So when it's performing the recursive lookup, it's going to use this name to decide whether or not it should be forwarding it to the target location that you mentioned. Something that I should point out is that this can do a wildcard match. So for example, you could type in just example.com, and anything that has example.com in it will be forwarded to that target. So www.example.com, onprem.example.com. In some cases, for some customers, you can even just use a root, so just a dot. And what that would do is end up forwarding virtually everything back to on-premises for you. So that's to simplify the number of rules that you need so that you don't have to create an individual rule for every single name. Then you just choose one or more target IPs. You can have multiple for a single domain name. And then you choose the outbound endpoint that you want to use. And so once you are done with that, you will be redirected to a VPC dashboard. And what you will see here are just all of the VPCs that have either an endpoint configured or that have some kind of rule applied to them. And with that being said, I'm going to give it to Jeff, who's going to go into more details about the rules.
Okay. So we're going to talk a little bit more about how the resolver rules and resolver endpoints work together. So when you create an EC2 instance and you spin it up, you're going to get an auto-defined rule set and default Route 53 resolver applied to it. And so, for example, if you create a VPC with 10.0.0/8, at the 10.0.0.2, there'll be a Route 53 resolver provided for that instance. So once you hit that, that is also accessible on 169.254, 169.253. And so you have to configure the enabling DNS support and enabling DNS host names, and assuming you have DHCP options set, the default, which is Amazon provided DNS, that .2 resolver will apply the default rule, the auto-defined rules to the Route 53 resolver and allow you to query out through it. So the auto-defined rules, what they do is they apply rules for private hosted zones. So first it'll try to match against any private hosted zones you have. And if it matches, it'll give back an answer for that. Next, if it doesn't match a private hosted zone, it'll go up and try a VPC name. So those are things like IP /10/10/10.ec2.internal. And if it has an address for that, it'll respond with that answer. And if it doesn't match any of those, the next step would be to recurse out to the internet and ask the authoritative name servers for that zone to get the answer and respond back to your instance. So next, what we've done is we've added the inbound endpoint. So the inbound endpoint is really just another ingress point into our Route 53 resolver. And so it has the same auto-defined rules. It'll take the same matching path and allow you to now query from on-prem. So now you have accessibility from your on-prem over Direct Connect, over VPN, over peered VPCs to that IP address for that inbound endpoint. And it'll walk through the same path. We're checking the private hosted zones, the VPC names, and we're recursing out to the internet. And really, the added benefit of, like Maritza mentioned, was the higher QPS rate, also available on the inbound endpoint. So now we want to control how the query is resolved. So then we've added custom rules. So these custom-defined rules will allow you to affect the path for the resolution. And so you can apply these new rules, and you can say, for a particular zone, I want to forward those queries out through an outbound endpoint, and then so maybe that outbound endpoint has a direct connect back to your on-prem. So you can take a domain and forward those queries back to your on-premise. And then system rules allow you to have almost like a jump point to apply the auto-defined rules and recurse out to the internet if you wish to have that auto-defined, that default behavior from the Route 53 resolver. So let's walk through a few examples just to put this in perspective. So what we've done here is the customer's defined a dot rule. So the dot rule is really like a catch-all. So if it doesn't match any of our auto-defined rules, it'll match against the dot. And in this case, the customer has defined a dot. And so that's overriding the system dot. So normally, like we said, the system dot will go out and recurse out to the internet. But in this case, the dot is going to forward to an on-premise IP address. So now when we get the query for website.onprem.mycompany.com, we'll first check the auto-defined rules. There's no private hosted zone, no VPC names that match, and now we're going to hit the dot. And then that will forward that query back to your on-premise name server at 1.1.1 out through the outbound endpoint that's bound to it. So next, let's just look at a VPC name. So we get a query for IP-10-10-10.ec2.internal, and that will take the normal path where it'll check the auto-defined rules. And in this case, it matches an auto-defined rule for VPC names. And so it'll jump to the system area and answer from that with the A record for that. In this case, it's A record for 10.10.10 for the IP address. So next, all our rules are working great, but our company has gone ahead and acquired another company. And so now we've integrated their network into ours, but they have their own authoritative name servers, and we want to be able to access them from inside our VPCs. So we want our services in our VPCs to be able to resolve their IP addresses. So what we're going to do in this case is we're going to add a forward rule for acquiredcompany.com, and we're going to send it over to the target IP address of 2.2.2. And we'll assume that that's direct connected to the rest of our network, and everything is all connected. And in this case, when we get a query for website.acquiredcompany.com, it'll go match that rule and forward the queries over to that. But let's say, for example, we also have a more complicated use case, and we have a subdomain.acquiredcompany.com, and we have a public hosted zone, and we want to get internet resolution for that. So how do we do that in this case? We can't forward it over to our authoritative name server on-prem because it doesn't have the answer. So in this case, we want to add a system rule. So we would add a system rule type for the subdomain .acquiredcompany.com, and that will jump to the system side of the pane. And you can see it'll match through no auto-defined rules, no private hosted zones match that, and so it'll go out to the internet and recursively resolve it from the public hosted zone. And then it'll respond with the answer that you want. So this is just a brief overview of some of the APIs. So we've got APIs for creating the endpoints, creating the rules, associating the rule. So that's really applying the rule to a particular VPC so that the rule will act appropriately. And then we've got the rule policy. So that allows you to share the rule across your different accounts. So let's dig in a little bit and see what that looks like when we use it with the CLI. So the first CLI command is creating a resolver endpoint. And the direction for this one is inbound. And so we've created an inbound endpoint, and we've got security groups. In this case, I just have one security group, and that's allowing port 53, let's say, and from our on-premise network. And IP addresses, because we have to specify two different subnets, we require two subnets, potentially the same subnet or different subnets. It's really for resiliency and load balancing purposes for you to be able to put those into your on-premise unbound or bind or whatever you might be using. And then we are not choosing any IP addresses for this and allowing Route 53 resolver to just pick from the pool of the subnet and apply those IP addresses to that endpoint. And then creating an outbound endpoint is very much the same. We're just changing the direction to outbound, and we could use different security groups. We could use different subnets. It's really up to you how you want to do that. So now we'll look at creating a rule. So we want to create a rule, which is a forward type rule, and this one is for onprem.mycompany.com, and the target IP address is 172.1.1.1. And we've chosen the outbound endpoint in this example. And so that's really just creating the rule saying, okay, when we match this one, like we said, it's going to go out to that outbound endpoint. But we haven't applied it to any VPCs yet, so it doesn't really take effect. So what we need to do next is associate that rule with a VPC or VPCs. And so you take that rule and you associate it to the VPCs that you want that rule applied to, and then it'll resolve your onprem.mycompany.com out through to that target IP address. And the next case would be for sharing. So many enterprises have multiple accounts, and you want to create one rule set. You want to create one outbound endpoint potentially, and share that with all of your different accounts that you have. So you could take it and you could apply a policy to that rule that would say share this rule with another account, and then the other account will have to accept it. And then on the other account, you can take that rule and apply it to the VPCs in that account. And they'll, again, get the resolution for onprem.mycompany.com. And then when you do that, then it's already bound to an outbound endpoint, which is in the other account, and it'll send those queries out through your direct connect back on-prem. So you'll be able to extend your resolution out to all those different accounts that you have. And then in order to monitor this, we have integrations with CloudWatch, so you can see the queries per second into the inbound and outbound endpoints. And so you can set alarms, you could do various things that you want to do through CloudWatch. Also, we have CloudTrail integrations so that you can see auditability of the APIs and track that as you see necessary. We also have CloudFormation integration so that you can provision the resources through CloudFormation and use that as well. So with that, thank you. And do you have questions?
Yeah, so at this point in time, we'll take questions.